You switched on me. Okay, nice to let me know. I wasn't listening to the lyrics well enough. So don't stop. Don't stop thinking about tomorrow. Mess me up, Will. Yeah, okay. Now you're trying to get yourself out of this. No luck, my friend. Okay, so we'll go your own way, right? At the end of the hour, Okay, Fleetwood Mac. We were carrying on a conversation up front here about Fleetwood Mac, and I didn't pay attention to what I was listening to. It was just, sort of feeling the beat and everything. Yeah, whoops. Okay, we're going to spend time on simple interest first, because first, a reminder. Tomorrow is a test day, and we are going to have 2 exams tomorrow. The first one will be in large numbers and scientific notation. You'll have about 20 minutes for that, maybe 25. It's a short exam. Then we'll immediately go to the second one, which is another opportunity on simple interest because I didn't feel good about what we did the last time around. So we'll see if we can do better. But I would like to remind you before we go to the simple interest tables we're going to do, page 174 in the orange book, 174. So if you'll turn to page 174 in the orange book. So whip out that orange book. Vitamin C time. Page 174. And let's go to the document cam. This is what you should see. Now this is an important piece of information, and this didn't go well on the test, where I ask you how many times you would compound semi-annually. 2. If you compound quarterly, you're doing it 4 times. Monthly, 12 times. Daily, 365. So there was a problem that I looked at in the last hour, and that's what we're going to go to now. And it's on the sideboard, so that's where we're going to start. Now, it's rather interesting thinking about interest. And you got on camera today. You just managed to get on camera. Okay. On semi-annual compounding, this interest rate at 10% is hard to get at a bank. Very hard to get at a bank. Stay where you are. I don't want you on camera. Okay, just have a seat back there. We only have so many people on camera per day, and Angelica already took care of that, so she had hers for the month. Now, at this point, in the Wall Street Journal this morning, there is a statement about what happens to somebody in their 20s getting ready for retirement. And so remember we did this problem. You're 25, and at the age of 25, you put money in the bank for 40 years. And I said, what happens if you could put it in at $10,000? So somebody walks up to you and says, $10,000, put it in the bank, leave it there, 40 years. What was our amount at the end of the 40 years? $245,000 if you just leave it there for 40 years. $10,000 compounded continuously. What was our interest rate we did? 8%. How are you going to get those kind of interest rates? Now, I was just told by one of my students in the last hour they found a bank that's now doing a 6% interest. Now, I don't know if that's on a long-term deposit. I have a hunch that it's not in a typical savings account. Where are you going to get interest rates like 8% or 10%? And that's the question. And so what the Wall Street Journal was saying, if you're going to invest money for 40 years, you can't live on the interest at the age 65 if you just put it in a bank account. You're going to have to put it in an investment fund. And where are you going to get things like 10%? In stock. No, basically stock investments. But you have to do it very carefully. But you will have something like between an 8 and 10% return long term if you invest your money wisely in a portfolio, and that's where you need a financial advisor and somebody to help you out. So this 10% we're talking about here, not very realistic. The other place you can get good return on your investments is what? No, not you still are going to have trouble on a CD getting up around 10%. Invest in property. I mean, basically, if you invest in property long term, so far, with the exception, there's only been one period of time in the United States that I'm aware of where investing in property would have just wiped you out. And what period was that? The stock market crash of 1929, wasn't it? So the early 1930s, if you have property, you probably lost it because the banks went belly up. Banks basically ended up having to close. And you lost money, you lost property, but for the most part, investment in property has given you long-term increases. And in Modesto, what have been the increases? Short-term, for 10 years. What has been your increase in 10 years? If you invested $100,000 10 years ago, what would it be worth today? About double. So if you invested $100,000 10 years ago in property, that house is probably worth $200,000. If you invested $200,000, the house is now worth $400,000 to $500,000. So you've doubled your amount. That's quite a return in 10 years. I think of Bob Hope, who invested in Los Angeles back in the 1900s, early 1900s, and got very wealthy. The problem when you're young, do you have that kind of money to invest? And say, okay, I'll buy 10 houses, all at $100,000, and you don't. You're lucky to get one house. Okay. We're going to take $100,000. We're going to invest it at 10%, and this is called semi-annual compounding. This is what I expect you to do tomorrow on the test. You're going to give me an interest table. So let's see what we first have as a formula. You get your interest by doing what? Principal times rate multiplied by time. So if I can get a 10% interest rate, here's what I do. I multiply 100,000 times the 0.10, and your time is the fraction of the year. And the fraction of the year is 1/2 the year. So we get out of this $5,000. Compounding period. Your interest is $5,000. So what is your balance? Let's slide over now just to this part here, Will, so I have some room to move. So I have now in the bank $105,000 at the end of the first 6 months. Now slide just enough to pick up the 1. Okay, second 6 months. My new amount that I have interest on for the 6 months is $105,000. So I put it down here. I multiply by 0.10, multiply that by 1/12, which, or 1/2, I'm sorry, because it's twice a year, and that gives me $5,250. I write that down and add it on to the 105 and get this number. Now I want you to try doing that. It's one thing to write down the numbers here. I'd like you to go ahead, take your calculator out. So you'll need your calculator out. And what we're going to do is take the 100,000, I want you to multiply it times 0.10 and divide by 2. Hit your equal sign. Do you get your 5,000? Do we agree? So you again, 100,000 times 0.10 and divide by 2 equals. You should get 5,000 on your calculator. Okay? Now let's come back to the document cam for just a moment. Now remember, we're doing semi-annual. So doing it semi-annually, we have what? We have it for 2 compounding periods. So there's 2 compounding periods that are involved. If I were doing it quarterly, what would I have changed in the problem? So as we come back to what I have here, this would have been a 4. rather than a 2. Now, when you get your $5,000, you have to add it to what? To the $100,000 you invested. That's where you're getting this $105,000. Now, will you do this calculation and see if you agree with the $5,250? Do we agree as you carry that through? And then you add these two numbers together to get the next one. We're going to do a third line here for you to make sure we can get this. So you see how I added 5,250 to 105,000 and got 110, 250. Now what I want you to get me is the third compounding period here. So this is the end of 18 months. You tell me what numbers to write in. So you're going to have to take now 110,250 times 0.10, and then we'll just divide by 2. That's the same as multiplying by 1/2. Okay, so 5,000, what number are you getting? 512.50? 5. Now, how are you saying it different, Tara?
I got 551.25. I don't know if that's wrong.
Is it 5,000? Did you multiply by 110,250 times 0.10 divide by 2 equals?
5512.5.
That's what I have written. We agree. Okay. So what is our new balance? No, my new balance. I have to do this added on to the 110,250. So $115,712.50. Do we agree? You don't agree? 762?
Yep, 762.
So I have $115,762.50 at the end of the third compounding period. Now are we in agreement? If I wanted to have you do it another one, do you understand how you just keep going? Just all the way you want to go. Now, if you do it instead of semi-annually and you do it 4 times a year, the difference being 1/4 in each of these instead of 1/2. And it's going to change all these numbers. But are we okay there? Now, Will, I'm going to change the order of what I'm doing here a little bit. I'm going to go down at the far end of this board. Now, here's my question. If I did it monthly, how would this differ? Instead of 1/2, it would be 1/12, correct? So here's the problem I'm going to put to you. And I don't want to go through the table this time. I want to use a shortcut in the calculator. And I want to compound monthly. And I'm going to put 100,000 in the bank, but I'm compounding monthly. I want to know the money in the bank at the end of the year. You're going to need your calculator to do this. And you're going to need the small version to make this work, the very simple 4-function calculator. So, Will, we're just going to pan down to the end, like panning for gold. So you ready to pan with me? Okay, I'll just keep backing up, bring a zoom in a little bit as we do that, and then elevate a little bit more. So this is a real challenge, okay? Further, further. There we go. There's where we went. This is what we're going to do. We're going to do 6-month compounding, 6% monthly compounding. So 0.06 is my interest rate. And I'm going to compound monthly, and all I want is the balance at the end of the year. That's all I want. Let's not get that much in over there yet. Okay. So what do you do in your calculator? You take your 0.06, you're going to divide by 12, and then I'm just going to move a little bit to this distance. So you're taking your 0.06 divide by 12, and hit an equal sign. You should see a .005. Add 1. Should hit an equal sign, I guess, probably. So you hit an equal sign after the add 1. So you get 1.005, correct? Now I want you to hit M plus. So we have it in memory now, correct? Now here's what I want you to do. I want you to do this 11 times. Times memory recall, 11 times. With nothing else, just times memory recall 11 times. And at the end of that, now we'll slide over, Will. At the end of that, you should get, I think, this number, 1.0616722. 772, thank you. Okay, so you want to bring just that much in, and I'll just walk off camera. Bring in just this much up here. So doing what we just talked about. That's good right there. Now what we did, I'll give you the answer first. We have 1.0616772. If I multiply that times 100,000, you'll get this number, $106,167.72. Now let's go through the steps again one more time, because I expect you to be able to use your calculator this way on the test tomorrow. Are we ready? Let's start over one more time. So what we're going to do, you're okay there. We're going to take our .06 and we're dividing by 12 and hit an equal sign. Now that's where at this point you're going to see 1.005. That's what you'll see then. No, you'll hit 005, correct? Sorry about that. So you get this. Then you add 1, hit the equal sign, and that's where I get the 1005. Now, when I hit M plus, what happens to this 1.005? It goes into memory. Now, I'm going to multiply by your memory recall, and you do this 11 times. You should get this number. Will you try carrying that through and see if it works? And you will need to do this tomorrow. Now, after you do the 11th time, you have to hit an equal sign. I should have made that comment. After the 11th time, hit an equal sign. And you should see 1.0616772. Do we do that? Have we gotten there? Bad English phrase. Have we gotten there? Yes. Did we manage to get there? One more time. Let's do this a few times until we're there. Start over. Turn it off, turn it on. That clears memory in these. So you get .06 divide by 12 equals, do you see 0.005? Add 1 equals, and you should see 1.005. M plus, it's now in memory. Now this last step, you have to be careful. You're going to do this sequence, which is times MRC, 11 times before you hit an equal sign. So 11 times and an equal sign. We'll let you take time to do that. Do we get 1.0616772? If you do, multiply by 100,000, and now that's your amount at the end of a year. Now question, what happens if I wanted to do it daily? What would be the differences? If I wanted to do this every day, this would be instead of 12, 365. The rest stays the same. And how many times would I hit times memory recall? 364 times. and that would give me the amount at the end of the year. Doing it daily. You remember there is a shortcut. Doing it continuously. Do we get it? That is what you have to be able to do for the test tomorrow and the last problem. Okay, we're at this point now. I'm going to slide back to a payoff table. So let's slide back here briefly. Okay, this is a classic payoff table. This was a problem that we set up, and I need to go over just enough to pick up the 500, Will. There we go. The payoff table. This is using a credit card. Here are the guidelines. You charged $500. The interest rate, 8%, which isn't bad on a credit card. Oftentimes it's 18%. And here's our agreement. We're going to pay 10% of the bill each month. So you look at your bill and you say, okay, I'm going to pay 10% of it. We want a payoff table. Now, I will try to make sure that your payoff table is on the test tomorrow so you don't have to enter the columns. So you're going to see the number of the payment, the amount paid, the balance, the interest, and your bill. Payoff table. So let's look at our formula again. The formula is still principal times rate by time, and this is monthly. Otherwise, you pay off a credit card on a monthly basis. So how do we get our interest for this first month when it's 8% and you have it for 1/12 of the year? So with your calculator, you should say, or you should do the following. 500 times the 0.08, and then just divide by 12. And you should get $3.33, which is what I have here. That's your interest. Now, what will the bank likely do? And I've rounded off here mathematically. The bank will probably charge you $3.34, but I wrote it as $3.33. So what is your bill now?
So you want us to write what the calculator says?
Round off with the calculator just mathematically. So we have $3.33, so your balance, your bill, 503.33. Now let's slide over just enough to pick up here. So at this point, and bring in a little bit tighter zoom. Thank you. We can see the numbers better that way. So this is what I'm billed the end of that month. So I bought it, I get a bill at the end of the month. They say you owe $3.33 interest. So your bill now is $503.33. How do you get your 10%? Shortcut. Move the decimal point to the left one place, and so I'm going to pay $50.33. Now what the credit card company is going to do, which is usually a bank, they're going to subtract that $50.33 from what? From my bill. And they're going to say your new balance before interest is $453. Then, what do we do with that $453? Multiply by 0.08, divide by 12, and you're going to get $302. What do you do with the interest? Add it to your $453. Here's your new bill, $456, 2 cents. How much do you pay? $45.60. So move the decimal one place over. Here's your new payment.
I do have a question on
Yeah.
On the 453, shouldn't you have 67 cents on that?
On the 453, if we had 50.33 that I paid,
Yeah.
and it was a 33 at the end, the 33s go off, giving me a 0.
Oh, I do. Okay.
Okay, and I'd end up with just the 453, agreed? I'm going to subtract this from here,
Oh, okay.
and there's a 33 cents.
That's right.
If I only owe 503, I agree, I'd have a 67. But with the 33 here and the 33 here, that just gives me a 453 in this case.
Okay, thank you.
You're welcome. 456.02. Then we pay what? 45.60, moving your decimal one place to the left. So now what do we have to do? Subtract. Do you agree that our new balance after I make my payment is $410.42? $410.42. By the way, this assumes what? You leave the credit card in your wallet, the purse, wherever you keep your credit card, you don't use it. Okay? So you aren't adding to your bill. This is tough to do. Now, what's the downside of paying 10%? Give me the downside. Well, you do get to pay it off, but not in a year. At the end of the year, you'll still owe what? About a third of this. So my guess is you'll still owe about $150 or so at the end of a year. So what do you do instead? Pay the 10% on the first one, but keep paying what? The same $50 every month. Don't decrease your payment. And that's hard to do because usually there gets less and less money at the end of the month. Boy, that sounds like that was low. Now, what do you then get? Your interest. Let's check this one out and see if it works. 410.42, multiply by your 8%, divide by your 12, and I think if you round off, you'll get 274. If you round off, correct? And so that gives you 413.16. Get the idea? We just did 2 rows. Tomorrow, 4 rows. Be careful. If I ask you for the 10%, this is going to change each time. But I may instead say what? Just do I might say do $50.33 every month. You don't then have to change your payment. That will get you paid off in 11 months, by the way. Any question there? Okay, Will, let's go back to the document, Cam. That's what it's going to be about tomorrow in terms of a test. I think I'll take the straight edge with me as we come back. So that's part 2 tomorrow. And back to center. Part 1 tomorrow. Large numbers in scientific notation, which is what we did the last couple days. Now this should go pretty straightforward. I'm going to review how we do that. I have some problems on the board from what we did in the last hour. And these are just some typical problems, and I'm hoping as we do these, you'll feel comfortable with large numbers in scientific notation. Before I do those, there's one problem I didn't review in the last hour, and I realized that at the end of the hour. So I'd like to come back to the one problem that you will see on the test. And that, I suspect, is about on page 86. This kind of problem I will have on the test. This is problem 5, page 86. So this is the point where you have written zeros and you wrote them for 1 minute, and we had 189 a minute as the record yesterday. So if you start with 189, how many would you write in a year? I expect you to be able to do that on the test tomorrow on large numbers scientific notation. So again, the setup for this is on page 86. Yes, you'll be able to use the calculator to do that, but you have to remember what to do. Okay, with that said, I'm done with camera 2 over in the sideboard, so if you want to be able to use both cameras up front, you're welcome to. But I'm going to go to the first problem that I have up on the board, which is behind me, and it's the upper left-hand corner, so I'm giving Will time to do that. This was a case where we started with this large number. And just a reminder, when you have a large number in scientific notation, the exponent for the power of 10 will be positive. One more time. If you have a large number in scientific notation, the exponent's positive. And then the other question, where do you want the decimal point in scientific notation? Here's my first number. Now the first number I have in positional notation. So this is the case where I give you a problem, positional, and I want you to write it in scientific notation. The rule is very constant. Go to the first non-zero digit to your right. The first digit, as I go from left to right, is the 7. I put the decimal after that digit. Then I ask the question, how many places do I move the decimal to get it back to where it was? The decimal was at the end of the number. We didn't write it, but it's understood to be there. So how many places did I have to move it? Well, I had 3 just to get it here, and then 6 more zeros, so that's 10 to the 9th. The trap, it's not the number of zeros. It's how many places you move the decimal point. Now, a question that was asked in the last hour, well, what would happen if I had 67? And by the way, this number, if we think about it, let's name it, because I expect you to be able to do that also. So let's take the top one. Just look at the monitor. Yeah, the top one. So that's thousands, millions, billions. That's 7 billion, 91 million. And you'd write that out in words. 7 billion, 91 million. I have a question. How do you sign billion? You just, okay, so you just keep adding on to it zeros. So if you have billion, you have to know how many zeros to add on. Interesting. Okay. So if I have 7 billion 91 million, and you could get a sore hand if we have a big enough number, right? Just think if you have a Google, you have to put a 1 and then followed by 1, 2, 3, 4, 5, 6 until you get to 100. You don't want me to do a Google. Okay. So we have 7 billion 91 million, but in scientific notation, 10 to the 9th. You do or don't? Good. I like it that somebody likes this. 67 billion. The decimal now comes after the 6. And my exponent is 10. To get all the way to the right. Okay. Then the question that was asked, well, and by the way, this was 67 billion, right? We talked about yesterday what we thought maybe the national debt was, and one of my students corrected me this morning and said it's at about 76 trillion. So this is just billions, so this would be 67 billion. If you went to trillions, you're where our national debt is. So that means another group of 3 zeros after the billion. At any rate, this number, thousands, millions, billions, trillions, this is where this came up because I was saying, well, if we had 3 trillion, well, let's do something here a little bit differently. Let's say it's 73 trillion, 567 billion, 91 million. That would be about where our national debt is. And so, how would we write that as a number in scientific notation? Your decimal goes here. So 7 point. Now, here's a question. If you're going to do this in scientific notation, how much garbage do you put in here? Well, we have a 5, 6, 7, 0, 9, 1. I could do that and then say times what? 10 to the 3, 6, 9, 12, 13th power, but most likely you'd get somebody saying, well, it's about 7.4 times 10 to the 13th. So what you would typically see here in the newspaper is round this off to, instead of 73 trillion, round it off to 74 trillion and say 7.4 times 10 to the 13th. We lose some accuracy usually when we do scientific notation. So one more time. This most likely would be written as 7.4 times 10 to the 13th, and that's not a very readable 7. I don't have any idea what that looks like. But it would be something like this, 7.4 times 10 to the 13th. That's what you would see reported. Now, if our national debt gets any larger, we could be approaching what? Quadrillions. It's bad enough that it's in the trillions. Is there any question there? Anything I can help with? Leanne? I'm not going to ask you to round off in the test. Is there a question that I can answer? Okay, the question is, why did I put my decimal between the 7 and the 3? I always start at the left, and in scientific notation, my decimal point comes after the first digit. So my first digit in 73 trillion is the 7. Now I have to be careful there, as you'll see in a moment, because if I have very small numbers, my decimal comes after the first non-zero digit. Now none of these digits are zeros in front of here, so it works here. But let's look at very small numbers. It's the other side of the coin. We started using scientific notation with very large numbers for very obvious reasons. But then, if we get to very small numbers, as we slide over now, Will, or go to the other camera, whichever you like, this was a problem in which, rather than 76 trillion, we decided to have a very small number. So let's try naming this one. And by the way, Leanne, in this problem, the decimals here, as I gave it to you in positional, slide just a little bit to the, thank you, Will. There's my decimal. Where do I want it? After the first non-zero, so it's all the way over to after the 7. Same rule works. Now let's name the number. This is not so easy with small numbers, and I don't push you on this in the unit, but it's what we did in our review earlier. Tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millionths, 100 millionths, billionths. So I have 76 billionths. It's a small number, not a lot. It's un poquito, small. Okay? How do I write it in scientific notation? Again, I need 7.6. Now, we're moving the decimal to the left to get back to where it was, correct? So if we're moving it to the left, a negative. The shortcut, you know you're going to have to get past all these zeros, correct? And there were 7 zeros there. And one more place to get it past the 7. So that's 8 places to the left, negative 8. Are we okay there? Now what I did was look at another number. This isn't nearly so small, but this brought up a question that was asked. I thought it was a darn good question. What happens if you have a 0 here? And why would you have the 0 there? Well, let me name this number, and let's see if it makes sense. Tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. Now the question, if I round something off to the nearest millionth, I might want that 0 because that's a measurement I made, and that's what it is, precisely to the nearest millionth. If I want to write it that way, in scientific notation, the decimal's still where? After the 7. The first non-zero digit is a 7. So I have 7.35. Now, is there any question about 10 to the minus 3?
No, you don't.
Because I moved it over. I'll get to the other moment. I moved this over. 1, 2, 3. Now the question, do I include this 0 down here or not? If I wanted to highlight that I had measured something to the nearest millionth, I put the 0 there. But my suspicion is most people would be confused. And so you most likely would find it written this way. But acceptable is this. Because that gives a different story when you get done, because now you're going to get this number written out, and that tells you that you had 0 millionths when you round it off. Okay?
So you'll accept it either way?
I'll accept it either way. Any question there? Now, when I do problems like this, do you understand that we're going in potentially 2 directions? I started with this, and I got what? This in scientific notation. I could just as easily give you this problem and ask you to do what? Go to positional. So I expect you to be able to go from scientific to positional, or from positional to scientific. Both big and small numbers. Is there any question in that? Now, what else do you need to be able to do? Let's slide over. This was a problem in which we talked about quadrillions. Now, this is positional here. And this is called what? Verbal notation. So what I expect you to be able to do is take a number like this and name it in verbal notation. Now, how do I know to go the other way? If I start with 10 quadrillion, how do I know it's this number? What's the key to help you here? It was with the Roman system.
The bars.
Okay, if it's 10 quadrillion,
Each bar represents 3 zeros.
okay, so if it's 10 quadrillion, that means you have an M with 4 bars. So an M with 4 bars. So the M itself is what? 1,000, so that's your first 3 zeros. Now the 4 bars says 1, 2, 3, 4 more groups of 3 zeros, and you had 10 of those. Hence, 10 to the 16th. One more time. To have a quadrillion says that you have an M with a bar, 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 bar. That's what the quad stands for. Each bar represents 3 zeros. The M represents the 1,000. So this says I have 1,000 with what? 4 groups of 3 zeros. So how many groups totally? 5 groups. That's 15 zeros. And I had 10 of it, 10 to the 16th. Now what else I do here sometimes is say, write this as a product of tens. So if I were to do that, I'd write what? 10 times 10 times 10 times 10 for how many times? 16 factors. And that's not the best thing in the world to be doing, but it'll work. If I don't, well, the question is, will I go past quadrillion, like quintillion or sextillion, septillion, octillion, nonillion, and so on? No. Okay? But quadrillions, I expect you to be able to handle. Here's another question that came up the last hour. Now, this number is a fairly small number. What's this one going to be? Tenths, hundredths, thousands, 10,000s, 100,000s, millionths, 10 millionths, 100 millionths, billionths. This is 1 billionth. Now, does that 0 in front matter? No. Why do we put it there again?
So you can see what the decimal is.
Typically to note there's a decimal there. So example that I gave yesterday, I believe, was where we talked about the medical area, and they have 0.5 cc's. So this was my example from yesterday, and saying if you did not see the decimal, you would give 5 instead of a half. So to make the reader aware of that, we do what? We put a 0 in front of the decimal because typically you don't see zeros starting numbers. So this 0 at this point probably isn't all that critical because your next digit is what? A 0. And so it's pretty clear, but nonetheless, you may still be expected in some applications to put that leading 0. But in terms of the number for the exponent, the decimal is technically where? In scientific notation after the 1. We don't usually write it there if I just have a 1. And then how many zeros? 1, 2, 3, 4, 5, 6, 7, 8. And add one more to get your negative 9. Point I want to make as we slide over a little bit on that, Will. Come over to about here. You could just say 10 to the negative 9th. 1 times 10 to the negative 9 is 10 to the negative 9. But be careful as I slide further, because as I now pick up this number, I did the same number but 2 billionths. That was where I was talking about the Apple I and Apple II computer yesterday that Wozniak designed. And if we look at that, 2 times 10 to the minus 9th, I can't write just like I did here. I have to leave it this way. Okay. Now, the rest of these are basically just trying to do some repeats. Make sure you've got it. If I start with 2.5 times 10 to the minus 4, the decimal goes 4 places to the left, and you can see you get 0.00025. On the other way, if I have 3.012 times 10 to the 5th, the decimal goes to the right 5 places. Technically, I could put it here at the end. We don't usually in that example. So that's the review. Tomorrow, I will collect the books. I expect you to have large numbers in scientific notation done. You have 2 tests you're going to take. I want to have simple interest done and look at that. So at this point, is it clear what's happening tomorrow? We'll replay this presentation tomorrow for those of you who are watching at home, and you get a second opportunity to look at scientific notation and simple interest. Will, we're going to go back to Fleetwood Mac, and this time we're going to go your own way. So have a great afternoon.